we're going to go over the balancing reactions redox practice together. So this is number 1. So for each one of these, it's asking you to write the half reactions and classify them either as oxidation or reduction, and then to balance the equation. So we'll go through all of those steps together. So the first thing we have to figure out how to do here is we want to know what is oxidized, what is reduced. So to figure that out, we have to assign oxidation numbers to all of the elements. Now there's a little bit of a shortcut here, because if you can definitely figure out one of them, then you know the other half reaction has to be whatever you don't have yet. So that's kind of one way to do it. So first thing I would do is look and see which ones go together. So H2O2 I know is going to go with O2 on the other side. And then the Cr2O7 has to go with the Cr. And again, it takes a little bit to kind of get used to knowing how to split it up. But the Cr2O7, the only possible thing that could go with on the other side is the Cr. So that leaves the O2 to go with the H2O2. So that's kind of a way to think through that. So then to assign oxidation numbers, what I can do is I'm going to start with a chromium, just because this one's going to be super easy. I know that's a +3. Over here, oxygen's a -2. There's 7 of them, so that would be -14. It has to equal a -2. So that means chromium, this would have to be 12. And since there's 2 chromium, that means it would have to be a +6. So for it to go from a +6 to a +3, it would have to gain electrons. So that means that's my reduction reaction. So then I'm going to take that down here, and I'm going to write that as Cr2O7 -2 goes to Cr +3. Okay, so then that means that my oxidation reaction has to be H2O2 goes to O2. Okay, so that's the easiest way to do that, is to find the easier of the two, classify it, and you know that the other one has to be that. Another way you can do it is you could split them up first and then see which side has to have the electrons. So we talked about how if the electrons are on the right side, then that tells you that it's an oxidation. If the electrons are on the left side, that tells you it's a reduction. So if you don't want to have to deal with the oxidation numbers, that's another way that you could figure those out. Okay, so then once we've done that, first step is to balance anything that is not hydrogen or oxygen. So if I look at the first reaction, H2O2 and O2, all that has in it is hydrogen and oxygen, so there's nothing else I need to do there. If I look at the bottom one, I have 2 Crs on the left and only 1 on the right, so that means I have to put a 2 in front of that one. Okay, so now those are balanced. Now I'm going to go through and balance oxygens by adding water. So over here, I have 2 oxygens on the left, 2 on the right, so I don't need to do anything there. On the bottom one, I have 7 on the left, so that means I have to add 7 H2Os on the right. Next, I have to balance the H's. So there's 2 H's here, and I'm going to balance H's with H pluses. So I'm going to add 2 H plus over here. Down here, I have 7 times 2 is 14. So I'm going to add 14 H's on the left. Okay, so now those are balanced. Now I'm going to do electrons. So on the top, I have 0 overall charge on the left, 0 and +2 on the right. So that means the only way I can balance that is to add 2 electrons. Then if I come down to the bottom, I have +14 +2. So overall, this is a +12. This side, 2 times +3 is +6. This is 0, so +6 over here. So the only way to balance that out is to add 6 electrons on this side. Okay, so then I have to take care of what's going on up here. So I need to make this 2 electrons up here be 6 electrons. So I'm going to have to multiply everything by 3. So then I have 3 H2O2 gives me 3 O2 plus 6 H plus 6 electrons. Then I can add it all together. 6 electrons cancels out. I also have 14 H pluses here and 6 up here. So that leaves me with 8 H pluses. And then everything else will stay the same. Plus 7 H2O plus 3 O2. So this then would be my final equation. Same thing here. I'm going to try to pick the easier of the two, and really on this one you could use either one of these. So let's use the O2 or the SO3s and the SO4s. So O is a -2. -6 has to equal -2. So that means this S would be a +4. Over here, -2 minus 8 equals -2. So that means this one has to be a +6. So if I go from a +4 to a +6, that's a loss of electrons. So that's my oxidation. So here under oxidation, I'm going to do SO3 -2 goes to SO4 -2. Okay, so that means the rest of it has to be my reduction reaction. MnO4 minus goes to MnO4 -2. Okay, so first step, take care of anything that is not oxygen or hydrogen, which I don't have anything there. Then I'm going to go to the oxygens and balance oxygens with water. So I need to add 1 water over on this side. The oxygens are okay down here, so I don't have to do anything down there. Then I'm going to balance the H's with H pluses. So 2 H pluses over on this side. Bottom one's okay, there's no H pluses in either one of those. Balance the charge. So this is 0, -2, -2 overall. This is -2 plus 2, because I have to take that 2 times the plus, 0 overall. So that means I have to add 2 electrons on this side. On the bottom one, this is a -1. This is a -2. So to get from a -1 to a -2, I'm going to add 1 electron on the bottom. Okay, now I have to make sure the electrons cancel. So this bottom one, I'm going to multiply everything by 2. So 2 electrons plus 2 MnO4 minus goes to 2 MnO4 minus 2. I'm going to add everything together. 2 electrons cancel out. Everything else gets brought down. So H2O plus SO3 minus 2 plus 2 MnO4 minus gives me SO4 minus 2 plus 2H plus 2 MnO4 minus 2. Okay, now this one is a different situation because this one is basic. So that means I have to add OH minuses to cancel out any H pluses that are present. When I add OH minuses, I add however many H pluses there are to both sides. And then what those H plus and the OH minus do is they make water. Okay, so now I have 2 OH minus plus H2O plus SO3 minus 2 plus 2MnO4 minus gives me SO4 minus 2 plus 2 waters. So this and this are going to make 2 waters plus 2MnO4 minus 2. And then the last thing I would do is reduce the waters. So I have 2 waters here. That's going to get rid of this one over here. So then that would just be 2OH minus plus SO3 minus 2 plus 2MnO4 minus gives me SO4 minus 2 plus H2O plus 2MnO4 minus 2. And again, you only have to do that when you have a basic solution.